Welcome everyone to my presentation today. Today I'm going to give a talk on data-driven development for automotive domain. I'm Toshika Srivastava, technical lead for data-driven development for autonomous driving. My prime focus areas are function and feature development, process method and tool chain development to enable these features end to end. And also I look into the safety concept for machine learning module, which can then help in verifying and validate these modules inside the safety relevant environment. Here's my contact info. Feel free to contact me in my LinkedIn profile. I'm very much interested in knowing different or interesting topics and feedbacks on my presentation. Where I am. So basically, I'm employed by Audi, but recently, if you have heard that the Volkswagen Group have started a new company, which is called Car Software Org, who is responsible for responsible for building the software solution for the mobility industry, especially for the Volkswagen Group brands like Audi, Porsche, Volkswagen. And right now, in my current role, I'm also supporting this organization from the starting so that we can have a company together who focus on the software development. Here is the outline of my presentation. In the starting, I'm going to talk about the basics or introduction to the autonomous world for those who have not been into this area. And then I will move towards the data-driven development concept. And then in the last but not the least, I will talk about the data analytics platform one can use within their organization. So if you're new to this concept, autonomous driving and driving assistance system, it offers multiple features ranging from comfortable intelligent driving, active driving, and also range up to the safety because safety is always our one of the concerns when we are delivering cars to our customer. This whole autonomous driving is divided into multiple levels. This is how the automotive company or automotive industries are certifying their driving software stacks. So it's basically from level 0 to level 5. Level 0 is normally we are driving in our everyday life where we have no assistant and we are responsible for everything. Then in some of the car, you also see kind of features where you can trigger the speed limits. And then based on the sensors, either if you have an obstacle in front of you, you reduce your speed or your car reduce the speed. Or if there is no obstacle in front of you, then the car accelerate to reach that maximum speed automatically. Those comes under the level 1 or assisted driving. The more you move towards level 5, the responsibilities are also moving from human to the machine. Level 5 is like a fully autonomous where driver is not there and machine is responsible for end-to-end functionality of the driving software. In whole this level, my area of work lies between level 3 and level 4, which is normally I call it highly automated driving and fully automated driving, where our basically our KPIs are on the human and machine in between based on the reaction time we set for these concepts. Then moving on, that was the introduction to the autonomous driving and autonomous level. Now I would like to move towards the data-driven development. And I will start with the basic. What is the data-driven development? So developing features, tools, methods, surveys based on the knowledge provided by the huge amount of data which you have stored within your organization. For me, from my understanding, that's basically the data-driven development. You learn features, patterns from your databases in order to do a certain functionality. One way of or one of the efficient way which commonly we know in our current generation to learn from the data is using AI and machine learning methodologies. As we are developing a software based on those methodologies, so they also comes under the product development cycle. So here I have plotted an image for you where you can see how the data-driven development product cycle look like. It's not basically a one-step process. You learn continuously throughout the whole development cycle until you reach a certain maturity or you fulfill all the requirements which is needed for your function to provide. So in this case, this is a structure. Every company can have their own different structure. This is I would say this is the one way of we are doing in our team. So we have a test car which records continuously data from the driving environment. Then we collect the data, clean it, we provide data enrichment, by adding meta information, additional information with the data file. Then we ingest this data to the data center, or you can also call it the data management platforms. And from there, this whole data-driven development, CI/CD, continuous integration and continuous development cycle start. Basically, then each team can take this data, depend on the area they are working on. They can prepare the data, because, for example, if you're working on perception, you prepare the data differently. If you are working for planning, you prepare the data differently. Then you label the data according to your specific use case. Then you train it, you test it, and then once this whole process is going on, and you reach a certain KPIs or metrics, or you can say maturity level, then either you deploy your machine learning module inside a code centric environment for a platform in the cloud structure, or in any hardware you are using for your integration. Then you test it. Different type of testing exists, like hardware in loop, software in loop, and stuff like this. Then you release this module into the car, even or to the platform which is hosted on the cloud, in order to again calculate or again collect the data based on the deviation KPIs of your function. Or you can just deploy a simple corner case or edge case detection in your algorithm, which then can run in the car again to collect efficient data. Then I would like to move towards the hidden requirements and challenges for the data-driven development lifecycle. So there is, as this is a new methodology, brings a new development life cycle for the product. You always have to bridge the gap between your classical development world and your data-driven development world. Then another process I would like to talk about the safety process, because this is one of the important, particularly in my domain, where I have to talk about, where I have to always make sure that the modules or the functionality I'm producing is safe to deploy into the customer fleets or the customer car, test cars and stuff. Then you always have to make sure that there are requirements, you always develop according to those. Otherwise you will end up in such an infinite space of development where you never reach your completeness of your algorithm. And then you have also challenges like scalability, reliability. So this is the picture which I wanted to show it here. Is basically one of the research paper from Google, published I guess in 2014, where they show that the machine learning module is a very small part of the whole system. You need a lot of infrastructure, tooling, configuration, management, resource management around your machine learning module in order to do efficient and scalable machine learning or a data-driven development for any product. So here, this like I always take into reference, and this was actually also the motive why we also move toward spending in the direction of spending effort in the infrastructure and tooling and stuff like this. Now, moving on towards, there are challenges, there are requirements, but still inside automated driving, we see the potential of machine learning or data-driven approaches to be a huge success, because you cannot do one-to-one, or it's impossible or next to impossible, I would say, to do one-to-one rule development for autonomous driving. So there are two strategies people or the companies are using within their whole autonomous driving stack. First one on the top is like deep diving, which does end to end. You put a raw sensor and you get the lateral and longitudinal control, which you then provide to your car to do the autonomous driving. Then on the bottom, you see another approach, which is more like a modular approach, where you break down this end to end system into smaller modules, basically specifying from perception to the fusion to interpretation to prediction, and then to the planning. And then you provide this lateral and longitudinal control to your car, which then can drive autonomously based on this information. You can one can choose any of these depending on their organization. I'm not recommending, there could be many other approaches also, but these are the strategies as most commonly used within the automated driving world. Here I would like to give an example of one of our um, use case which we are developing um, as a concept in our team, which is called lane change. You see on the top you have a driving environment. You see there's a lane, there is a cars in the field, and this coming out from the camera and other sensors. And then on the bottom is the prediction from the neural network. I would like to show this video to you, and meanwhile I will tell what exactly is happening. Yeah, so here you see these are the car, and we are predicting if the car is going to do a lane change or drive straight. Lane change basically has the three classes: straight, left, right. And now you see the car has moved the right, and then the prediction was also at the right. And then you are predicting for every vehicle which direction they are driving, if they are driving straight or doing a lane change or not. This is a simple example I would wanted to show you so that you get a idea which kind of modules we are developing using our data-driven development life cycles. There are other areas also for the data-driven development, not only the function and feature. You can use machine learning or neural network-based approaches into data management, data science, infrastructure, simulation and assessment, detection of anomalies and stuff like this, in order to provide the capability of deep neural network, machine learning, or AI, whatever you called, to do the efficient or to solve the problem efficiently. So moving on to the next or the last part of my talk, I would like to talk about the data analytics platform, because I feel that's also one of the things I wanted to go within my talk. I don't want it to cover everything in this time and focus my energy into one direction. So there I see potential for the data science environment, or how the data analytics tool we have set up, which kind of algorithm we are using in order to get the information. So I would like to go towards this part from the overall activity we do with the data-driven development. So before starting from this analytics platform, I wanted to give a bit information about why we need why we need a smart analytics platform in order to analyze the data, in order to plot the data, in order to get a statistic out of the data. If you see the example here, there's a car which having, for example, 25 environmental sensors coming out from camera, radar, ultrasonic, LiDAR, maps, stuff like this. And all these sensors collect data at a different timestamp or different frequencies, and also have a different um, how you call information in different formats. So if I take on average, for example, or if I take example here, that how much data a development vehicle is recording per second is 8 gigabyte, for example. And this is just a number. From here, you can imagine the more sensors you add within your autonomous driving, how much data you collect within 1 second, and how much data you need to store, you need to analyze. And so this is basically, and these fleets are recording 24/7 the data, and the task of the data analytics platform is to provide efficient interface to access those data, to search those data, and also to visualize those data, and to add more information with the data recorded with these cars. So how the data structure and the metadata format looks like. So here you see there are three measurements. For example, measurement A, B, and C. Those you can say it is a driving campaigns. And then for each driving campaign, you have recorded different scenarios. So file 1 recorded one scenario, file 2 recorded different scenarios, file 3, and so on. This is just an example format. And on the row wise, you see there are different names, so called flex ray, video, ECUs, X, Y, um, Z, and all. These are basically just a type of signals you are getting within each recording. Now, if I talk about the metadata, so in a high level, when you record a measurement, you get like a basic information with the file. So like you have when the data was recorded, at which date, which time, what was the vehicle ID, what was the description of the core data, the stream, the signals you use within the data files, which were the software version or the sensor versions were used when you recorded this data, and also it comes with a different type of labels you can store within data like events, sequences, and stuff like this. Now, if you have these kind of data and think about this 8 GB of data recording per second, how much data you have. So you don't want to visualize all the data because sometime within a second nothing changed and it's just repetitive data. What you do, you take samples from each files, which basically reduce your timestamps, so you don't have to have like a repetitive data. You can select, okay, if there are some errors or not, you can visualize this on a small set of data coming out from each files. And this also basically reduce the content for the platform and environment on the dashboard you are using into your analytics platform. So this is one of the way you can use it to make your data format or data structure visualization within your analytics platform to be efficient. There could be many other ways. This is basically the framework for the data science and data analysis. As you say, here because if you have a team or if you're working for autonomous driving, you have a different functions team or a different features team, and these and every feature team or every function team have a different requirement. So for example, if someone is working in the perception team want to analyze their data differently than if someone is working in the planning team, because they need different type of information. So you need a modular workflow when you want to do a function or a feature specific data analysis. Then you can also always have a standard algorithms in order to select the data, filter the data, resize the data, bind the data, and all. And then for plotting or for visualization, you can use interactive charts, plots, maps, so that you know where the data was recorded, which other signals are there, their distributions, and all. In order to access the data with the data management platform more like smartly or efficiently, you need to have like a smart or structured data management system there with a smart search option. So here there's like a flow going from the bottom to the top. You see that's a test fleet car who records the data just as I said, 8 GB per second, for example, ingest the data to the data management or a data storage. Then you select those data, you define those data, okay, what the data it is with the meta information and stuff like this. Then you clean those data, you prepare the data accordingly. So if you need, for example, have a chance of adding more information from some kind of advanced modeling like mathematical and physical model, or if you have additional information coming out from maps, from features you want to add also with those dat files, you can do in this step. Then you add or you append this information to the meta information, which basically then you have a reduced data because you have already cleaned it, and you remove all the anomalies and stuff like this. Then you transform this data into a model you can use within the team and you can interpret, and then you create a new knowledge based on these data sets, and which is then really helpful for the function team and feature team in order to develop their functions efficiently and properly. So this is basically a sample framework for data science or for data analysis. One can think about it or one can implement it. Now, so if you ask me how how the visualization look like. So you can have a different level of visualization. So for example, here on the left, you see the evaluation of driving campaigns. So how you can do, because if you're thinking about driving campaigns, it's more like, okay, this car is recording data into this highway in this country in this city and stuff like this. So the information is huge. So you have a visualization like a map perspective, so that you can say, okay, which area, which roads you have driven and stuff like this. And then on the right, you see visualization of the results based on the scenario. So then you go more in detail to the signals which the recording campaigns are producing, like velocity, object list, and stuff like this. Then you can visualize it differently. So these can be one of the two, or a possible or example to visualization you can do for in your platform, basically. Then I would like to talk about the data enrichment, because this is one of the important thing you want to have as information within your data files, so that this is like highly informative, and you can generate so many statistics out of it, and can also use within the feature and the function team, or the or the product teams, in order to make a meaningful test cases, test scenarios, development scenarios, and stuff like this. So here you see this on the right is a basic, you call the data, you ingest the data to the data management platform. It can be, then you can either visualize this data to your working space, for example, in my laptop, or you can also upload this data to the cloud and then connect to the cloud to visualize it. So you can do multiple things there. Then what you can do is in this cloud, or when the data is stored into the data management, you can add information. So information about the vehicle, information about the test setup. So like why this data was recorded, for which kind of customers, like a parking project, or is it like a highway pilot project, or urban scenario project, and stuff like this. Then you add this information. Then you also add metadata information, for example, semantic segmentation. You basically do all kind of mapping and correlation for the data in this process. And then the top one is more scenario. So you create different models, different mathematical, different machine learning models, where you generate scenarios from the data streams, and then you tag them so that you can use this information when you're doing the function development or function testing in the end. And then you add this information to your data files, or together with your data files, and then you can then connect it to the scenario editor, and then you can generate different variations over the scenarios, or you add this information for your testing results, and etc. Here you see I have plotted increasing effort chart, because the more you go from vehicle setup, test setup to scenario, you need more effort or more advancement in methodology, or technical solution, in order to bring the meaningful information content out from these data files. And now from here, when I move next to my presentation, I would like to talk about some of the methods one can use in the top, where you need most of the effort, in order to gather the scenario information from the data file, where you don't know exactly what's happening just from the raw data stream. I would like to give insight or glimpse about two possible methods you can use. The first one is scene grid recurrent neural network, which is one of the way to finding unknowns from your data stream. And here you see you have a driving data. So basically at each timestamp you have information about your objects, about traffic light, traffic sign, lane marking, and stuff like this. This is like a normal driving data look like. Then you plot this information to a scene grid, also to each time space. Then you extract the features like a spatial features using convolution neural network, and then from there you extract the temporal features using LSTMs and time recurrent networks. And from there, when you have a feature space, you can do a different task. Either you cluster those information, you use this to label it. You can also use this feature space in order to detect the anomaly within the data stream so that you can clean the data and stuff like this. So this is like a one of the way you can find these unknown and unknowns from your data stream, which is then can be used in multiple ways. The next Basically, the next one I wanted to talk about, finding unknown unknowns from the embedding. So here what you do is you have individual information channel for each driving state. Then you create a permutation of these bind channels, which is result to a driving state. And there you have input, then you produce a one hot encoding of those input, and then you have a input layer, hidden layer, output layer. And there you basically extract the information about about the driving states from the embeddings of the hidden layer. So for example, here you see if the driving state occur in the same context, the distance between the two states will be like really close to each other. And then if you have, if the driving states do not occur in the same context, then the distance will be like really large. So this way you can find the meaningful information from the embeddings, or the intermediate layer or hidden layer, to tag and to know about the scenarios within your data streams. These are the two example methods. You can use it, or one can use it, or we are using it in one of our data analytics platform in order to find the unknown unknowns. Now, moving on, I just wanted to give you how a cloud workspace data science dashboards look like from a visual perspective. So you have like a Jupyter notebook where you can like extract like data, do some kind of analysis on the data. Okay, when the data was recorded, what was the location, what information is, how big the data is, and stuff like this. And then you have like you can create all the visualization of the plot, a statistic, how many timestamps you have in your data, how the distribution look like, when you have like edge cases, corner cases, in which part of the world the data was recorded. And this is just a visual, how the visualization or the data science or data analytics platform look like on a workplace basis. With this, I am coming to the end of my presentation. So I have talked about the autonomous world, how it looks like, what different level. Then I talk about what is data-driven development, challenges, and stuff like this. And in the end, I just focus my talk on the data analytics platform, because which I personally believe is the core. Because if you don't know how to efficiently smartly access your data for your functions, then it just you will be always be in a small scale prototypical solution. And for scalability, it's very important to have a good data analytics platform within your organization or within your team. And this is just with this, I just wanted to give example like how different level of information you can have, how you can plot, how you can do certain tasks within this platform. With this, I would like to end my talk. Thank you very much. Again, here's my contact information with my name. Please feel free to contact me. Another thing I wanted to mention, if you would like to support or join our team for the future software mobility, feel free to join it. We are hiring. So that's all for the day. Thank you. And now I'm open for the question.